5.6 is on geometric sequences. This is something that we talked about before, but I want to make sure you understand this essential question. How are geometric sequences related to exponential equations? Unit 5 is on exponents. Unit 5 is on exponential equations. So let's look at this example. This is like number 9 in your notes, or not on your worksheet, I should say. On your worksheet, number 9, I have a sequence of numbers: 3, 6, 12, 24, comma, ... means the pattern continues. I bet you know what the next number would be. If you know what the next number would be, say it out loud.
48.
Awesome. If you said 48, you are correct. You know what's happening with these numbers. You can predict the next number. These numbers are created, these are called a geometric sequence. And we're going to define that in just a second. But what I know about this geometric sequence is, I know what the first term is. A of 1, A, parenthesis, 1, end of parenthesis. What that means is I know what the first term's value is. The very first number in the sequence is 3. I also know what R is. R is the same thing as 2. And what that means is what are we multiplying by to get to the next number? 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. That's how you got 48. You just multiplied, saw it was multiplied by 2, or doubling, double, 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 and that's what R was. R was equal to 2. So if you don't know this by now, here are my 3 little definitions. Geometric sequences have a common ratio. That's our R. The common ratio R is sometimes greater than 1 and sometimes less than 1. Do not assume it always has to be a whole number. It could be a fraction. And what is A of 1? A of 1 is our first term. What's nice about this particular section is that a lot of you will be able to do this if you know these 2 things. If you know what A of 1 is and you know what R is, you're going to be able to write a geometric sequence. Chase.
I don't understand R being 2.
Why is it 2? Okay. The reason why the common ratio is 2 is because how did I get from 3 to 6? How do I get from 6 to 12? How do I get from 12 to 24? What am I doing to those numbers? We're multiplying by 2. We're multiplying by 2. We're multiplying by 2. We're multiplying by 2 for this pattern. That's what the definition of a common ratio is. What are you multiplying by? It could also be what you're dividing by, just so you're aware. And so that brings us to this formula, which you are going to be writing down a lot. I highlighted it because you're going to be using it in section 6. The explicit formula for a geometric sequence. The explicit formula for a geometric sequence. So I wrote explicit and I wrote geometric is a of n, a parenthesis n, is equal to a of 1, and I underlined a of 1, times r in parentheses, and I underlined r, to the n minus 1 power. You do not have to memorize this. I will give this to you on any quiz or any test. It will be on the board. Yes?
Wait.
Okay. I will give this formula to you on any quiz or any test. If the reason why I have this underlined is because when we did this for arithmetic sequences back in Unit 4 or Unit 3, we only replace what's underlined. So I only replace the r, I only replace the a of 1. So let me just show you how this formula works. Okay? Earlier we had this example. 3, 6, 12, 24. There is an explicit formula for this rule. All I have to know is what is a of 1, and I can write down the rule. See how this says a of n equals? I don't change that. A of n equals. Instead of a of 1 means what's the first term? The first term is 3. You replace it. You only replace what's underlined. Then you go and see what's r. R, what are you multiplying by? You're multiplying by 2. You replace the r. And then you leave this n minus 1 alone. This formula I have boxed in here is the explicit formula for number 9. Rachel.
What is the n minus 1 supposed to be?
N is going to represent the term number. Let me point an arrow to that n. N is equal to the term number.
So if you plug in 12 and you'll...
No, the 12th term number. For example, okay, so you see how this is the first term, the second term, the third term, the fourth term? Remember how we said it was going to be 48? We could find the fifth term by plugging in 5 right here. 5 minus 1, and do 3 to the 5 minus 1 power. Let me show you. 3 times 2 to the 5 minus 1 power. See how that's 48? That's the next number. And what's the advantage of this formula? Now, instead of us having to go number by number, I can say, what's the 100th number? What's the 1000th number? And you'll be able to take a shortcut without having to multiply all those things by hand. Right? Okay. Let's look at number 11. Let's try an example and see if you understand. The directions for number 11 says, write the explicit formula for the geometric sequence. Number 11 says 140, comma 70, comma 35, comma 17.5. And I want to show you something on number 11 because number 11 is slightly difficult for one reason, but let's go ahead and do this. Here's the first thing I want you to figure out. We need to know what a of 1 is, and it's a very easy question. I'm going to put a of 1 equals blank. I'm almost positive all of you will be able to figure out what a of 1 is. As a matter of fact, I want you to say it out loud in just a second. So what is a of 1 for number 11? Say it out loud.
1.
Those of you who said 140, you are correct. I heard everybody but 2 people get that correct. Good job. If you don't know what a of 1 is, it means the very first term. the first number. A of 1 means the first term's value. That's what it is. Now, R is a little bit different in this problem. I'm going to work out what R is for you. Rachel? Okay. If I want to figure out what R is in the previous problem, all I really had to do was this number divided by this number, and it should equal that number. 12 divided by 6 should equal the ratio. 24 divided by 12 should be the ratio. If ever I want to find out what the number is, all I really have to do is take a number on the right and divide it by the number on its left. Let's go ahead and take one of these numbers and divide it. 70 divided by 140. And I'm going to punch it in on my calculator. I bet you some of you know what it is. What does that mean? That means your common ratio is 1/2. Can your common ratio be a fraction? Yes, it can. Especially if the numbers are going down. If the numbers are going down, let's take 140 and multiply it by 1/2. What's half of 140? What's half of 70? Does it work? Is it the same thing? All right, now you know what A of 1 is. Now you know what R is. What is the explicit formula? You should be able to write it. Go ahead and write down what your guess is, please. And then I'll write my answer in just a second. Write it down. See if you can get it right. For each one, you're checking to see what you're multiplying by. You're dividing. Now I'm going to write down what I got for my geometric sequence. I'm going to write A of n. That doesn't change. I leave that alone. Equals. That doesn't change. It's not underlined. The only thing I change is this A of 1, which is 140. Times in parentheses. My R is 1/2 to the n minus 1 power. This is what you should have for the explicit formula. Let me box that in. And I'm curious, show of hands, how many of you got that correct? Please raise your hand. Oh, that's awesome. Everybody except for like 3 people got it right. Wonderful. I'm happy with that. I can live with that. So that means you understand the explicit formula. Jesus?
I'm an old school. We did f of n equals f of x equals f of n minus 1.
Okay. I'm hoping you can, what's the word, adapt. I hope you can adapt here. We use A of n if you can, because that's what our particular book does. I will prefer you to write it this way because that's the formulas I'm going to give for everybody else. Okay, just so you're aware. That brings us to the second kind of formula, which is called recursive. The recursive formula is similar to the explicit formula, except it's a little longer. Recursive formula for a geometric sequence is A of 1 equals blank, semicolon, A of n equals A of n minus 1 in parentheses times R. And I only have 2 things underlined right here and right here. These are the only 2 things you replace. Once again, you do not have to memorize this formula. It will be given to you on any quiz or any test. You have to know how to use it or how to plug things into it. I think I have only 2 more examples for you, and then we'll be done. Right there. It says write the recursive formula. Recursive. There's an R right there. Write the recursive formula, and this will be like number 13. Number 13 says 1, 7, 49, 343. And just like the explicit, you need to know 2 things. You need to know A of 1, and you need to know what R is. I'm almost positive you know what A of 1 is. Look at it. What is A of 1 in this problem? What is it? If you said 1, you are correct. That's the first term. Good job. Now, what is R? What are you multiplying by to go from this number to the next number to the next number? What are you multiplying by? Good. You know your 2 pieces of information for your recursive formula. You write everything the same except where it's underlined. You're going to write A of 1 equals blank. You're going to write A of 1 equals what number? You just told me, 1. You're going to write semicolon. You're going to write A parenthesis n equals A of n minus 1. And then you're going to change that with a 7 and change that with a 1. I'm hoping that's easy. I think it is. If you have the formula, you know what it means, you got it. It's a piece of cake. One more example?
Yes.
This is like number 15. The numbers are a little bit trickier. 512, 384, 288, 216, comma, dot, dot, dot. The pattern continues. A of 1 is going to be easy. It's the R that's going to be a little bit harder here. If you're not sure how to get R, I wrote down on the side here a little side note for you. If you are trying to figure out R and you don't know how to do it, you take a right number and you divide it by the left number. The right number divided by the left number, that's what R is, as long as they're consecutive. 288 and divided by 384, or 216 divided by 288. That will let you know what R is. If you have a calculator that does fractions, I hope, we can do it as a fraction or we can do it as a decimal, doesn't matter. What is R? Figure it out. Riley?
4/3.
Close. Right number divided by the left number. Yeah. So Riley figured it out for us. It is 3/4 is what R is. So I have to write the recursive formula for this. A of 1 equals, what's our A of 1?
512.
Perfect. Semicolon, A of n equals A of n minus 1 times, and Riley told us what the R value was. It was 3/4. If you put 0.75, that's fine as well. When we did these notes, or when I created these notes, I focused on the problems that I felt like, oh, they're going to need to have how to do these ones, but they'll be able to figure out R. They'll be able to do all the other stuff. There's only one other sets of questions on 5.6 that I want you to know how to do, and that is it geometric or is it arithmetic? Here's how I tell. It is geometric when you're multiplying or dividing by the same number every single time. It's geometric when you multiply or divide by the same number. It's arithmetic. Some people call that arithmetic. It's arithmetic when you add or subtract by the same number every single time. When you have that down, that is the end of our notes.